All right, so in this video, we are going to talk about pH and how to make some calculations. So pH is defined as the concentration of hydronium ions in a solution. And we saw in an earlier video that a hydronium ion is an H3O plus because water has accepted a proton to form that hydronium ion. We also saw the terms dissociation and ionization in a previous video. Let's go ahead and look at these as to what they actually mean. Dissociation is when an ionic compound creates ions when dissolved in water. So sodium chloride dissolved in water forms its two ions. That is what we mean by dissociation. Ionization is for molecular compounds, acids in particular. All right, so hydrochloric acid, HCl, if we were to draw the Lewis structure for hydrochloric acid, these are both non-metals, so it is a covalent compound. It does have this covalent bond here, but acids do have the ability to ionize, meaning ion, that root of the word ionization, to form ions. So, because of the electronegativity differences between a hydrogen and a chlorine and the polarity of the water, there is an attraction here between the partial positive and negatives of the water. This is a very polar bond, so the hydrogen, even though it is a covalent compound, the hydrogen is very happy to leave and go over and join in with water to create hydronium ions and chloride ions. So an ionization is an acid. It donates a hydrogen to make that hydronium ion. Now, our pH scale. Let's review our pH scale. We have seen probably in previous science classes that our pH scale goes from 0 to 14. And let me see if I can't get this all the way on the screen. Okay, where 7 is neutral. 7 at neutral, the hydrogen equals the hydroxide. So if the concentration, and that's what these brackets mean, remember brackets are concentration, when hydrogen concentration equals hydroxide concentration, that forms water, which is neutral. The further away I go from 7 towards 0, the stronger the acid it is. The more hydronium ions that we make, the stronger the acid, because remember, weak acids do not ionize completely in water, so they have a low concentration. A strong acid ionizes completely in water, forming all ions, so we have a high hydronium concentration. A weak base is going to be a base that has a small amount of hydroxide. Now keep in mind here, it's important to remember all solutions when we're talking about acids and bases are going to have H plus and OH. It is really, when we're looking at it, which one has more. Acids have more hydronium than they do hydroxide. Bases have more hydroxide than they do hydronium. As I go away from 7 towards 14, my hydroxide ions increase. All right, because a strong base is going to dissociate completely to create all hydroxide ions. So I have a large concentration of hydroxide. Whereas a weak base does not dissociate completely, so we have a low concentration of hydroxide ions. Now, one additional thing, we're going to go ahead and throw this in, and we're going to use this in a lab. An indicator. What is an indicator? An indicator is used to determine if a solution is an acid or a base, and indicators work on color change. So indicators are a different color when an acid and a base. So the color of which that indicator is at an acid is one color and at a base is another color. And the most common one that we use in this class is phenolphthalein. Phenolphthalein is pink in the presence of a base, but it's colorless in the presence of an acid. So you can tell that the solution has become basic when it goes from colorless to pink. And we'll get to see that in the lab as well. We'll work on that. So now let's go to this worksheet that I have provided for you on Canvas. And let us fill in a flow chart. The concentration of hydronium ions, I can use that to find pH. All right, and if I want to find pH, if I know the concentration of hydronium ions, I'm going to take the negative log of that concentration. Now, I can take pH to find my H3O plus as well. I can go backwards. If I know pH, I can find the concentration of the hydronium ions by doing 10 to the negative pH. P meaning negative log. So anytime we have a P, P is negative log. I can also find the POH by adding pH plus POH equals 14. If I have the concentration of hydroxide ions, I can use that to find the POH, where P means negative log. So I'm going to negative log the hydroxide to get my POH. If I have my POH, I can find my OH by doing the opposite of negative log, which is 10 to the negative POH. Now, if I have my H3O plus, I can go direct to my OH as well, where KW has a value of 1.0 times 10 to the negative 14. All right, and check out our pH scale there, goes to 14. And that is going to be equal to the concentration of the H3O plus times the OH minus. So the hydronium times the hydroxide, where KW is my equilibrium constant for water. Now, we don't really know what an equilibrium constant is yet. This we will further explain in our next unit, all right, when we talk about equilibrium. So let's do some practice problems here. All right, I have a pH of 8.5. I can find the POH, all right, if pH plus POH equals 14, then if I do 14 minus 8.5, what is my POH here? My POH is 5.5. I can take my 8.5 and find my hydronium ion concentration. If I know the pH, I just do 10 to the negative pH. So 10 to the negative 8.5, and that's going to give me a value of 3.16 times 10 to the negative 9th. Now, for my hydroxide, I can choose to use my KW, or I can choose to use my POH value. All right, if I know my POH value, I can do 10 to the negative POH, or I can take my hydronium ion concentration, plug it in. All right, so either way works. It doesn't really matter. You'll get to the same answer. I find going 10 to the negative 5.5 is actually a little bit easier since I have that value. All right, and so I'm going to use that to find my value is 3.16 times 10 to the negative 6. Now, is this an acid or a base? Acids and bases are defined as the concentration or pH, is defined as the concentration of hydronium ions. This is the value that we use. A pH larger than 7 is a base. Okay. All right. Let's do the next problem. I have my H3O plus. Let's practice using our KW expression. All right, so if I want to take my H3O plus to find my OH, 1 times 10 to the negative 14 equals my hydronium ion, 6.89 times 10 to the negative 11. And we're going to multiply that by my OH. So when I divide both sides by this 6.89 times 10 to the negative 11 value, I am going to get a hydroxide concentration of 1.45 times 10 to the negative 4th. pH. To find my pH, I can take the negative log of my H3O plus, so my negative log of 6.89 times 10 to the negative 11 is going to give me a pH here of 10.16. Now, my POH, we've already seen, I can subtract out the pH to get that, but we saw that we could also, if we have the hydroxide, we could take the negative log. So let's just practice doing this one a different way than we did up here, all right? So if I have the hydroxide ion concentration, I can negative log it, 1.45 times 10 to the negative 4th, and that's going to give me a POH of 3.84. So you could have subtracted 14 minus 10.16, and that also gives you 3.84. This value, again, is larger than 7, so this would be a base. Okay. Now this does make sense because look right here, I have more hydroxide than I do hydronium. The negative 4 is a larger value than negative 11, so that makes sense. I have more hydroxide, which is basic, than I do hydronium ions. All right, let's do another problem. I have my 4.21 times 10 to the negative 9, so I'm going to choose to honestly negative log that value because I feel like to find my POH. So the negative log of 4.21 times 10 to the minus 9 is 8.38. Since I now have my POH, I'm going to subtract that from 14 to find my pH of 5.62. And since I have my pH of 5.62, I'm going to choose to do the 10 to the negative pH to get my hydronium ion concentration, which is going to be 2.38 times 10 to the minus 6th. My pH value is less than 7. Since I am less than 7, I am an acid. And again, this does make sense because look right here, negative 6 is a larger value than this negative 9, or 10 to the negative 6 is larger than 10 to the negative 9. I have more hydronium ions than I do hydroxide. So that does make sense. All right, let's do one final one. All right, POH is 9.4. All right, so if I do 10 to the negative 9.4, that is, if I do 14 minus 9.4, that is going to give me a pH of 4.6. pH is less than 7, so this is an acid. And now from here, I have my pH value, so I can 10 to the negative my pH to get my hydronium ion concentration, which is going to be 2.51 times 10 to the negative 5th. And if I have my POH of 9.4, I can 10 to the negative 9.4 as well. So this is 10 to the negative 9.4. Let me make this, I'm kind of writing it like it's a minus and it's not. Let me make it look more like what it's supposed to be. 10 to the negative 9.4. Okay, so that is going to equal 3.98 times 10 to the negative 10.